this video, I want to go over the integration of the natural log function and the exponential functions. And all I'm really going to do is go straight to examples. The reason is I think it's easier to understand the integration of these two functions by just doing a lot of examples and kind of getting the drift, understanding how to work them out. The only thing I'm really gonna use as a guide to show you where the integral comes from, or the antiderivative comes from, is using a quick reminder of the derivative for the natural logs. So remember that the derivative of the natural log of the absolute value of x equals 1 over x. And when we apply the chain rule, this one is with the chain rule, the derivative with respect to x of the natural log of the absolute value of u is 1 over u times u prime. And the derivative rule for exponential functions is derivative with respect to x is e to the x. I'm sorry, the derivative with respect to x of e to the x is e to the x. And the derivative with respect to x of e to the u is e to the u times u prime. So, whoops, wrong button. That's the rule for integrating the natural log function. So, the integral of 1 over x dx is equal to the natural log of the absolute value of x plus c. Don't forget the plus c. And integrating 1 over u du is equal to the natural log of the absolute value of u plus c. So it gets a little different when we apply, again, the chain rule. Or in other words, we go from the reverse mode of the chain rule. And I'll explain more with examples. So let's start off with this problem. So we have the integral of 2 over x dx. So first thing, what you don't want to do, so what not to do, don't do this. Don't say this is the integral of 2 to the x to the negative 1 dx, which is then the same as 2 times x to the negative 1 dx, and then say, well, we've done this before, and all that is 2 x to the negative 1 plus 1 over negative 1 plus 1 plus c. Then you're going to see there's a problem, because negative 1 plus 1 is 0. Okay? And that's not correct. Mainly that 0 in the denominator kind of makes this all wrong. This is all wrong. Okay? So this is what not to do. So let me show you what you would do. So what you do want to do here is you can go ahead and use that constant rule and take out the 2 and write 2 times the integral of 1 over x dx. And then you can easily apply the rule that you just learned. So 1 over x, the integral of 1 over x is the natural log of the absolute value of x plus c. And I think this answer would be just fine. You can also take this a step further and use a property that you learned back in either trig or algebra 2, where you send the 2 up and write it as an exponent, and write natural log of x squared plus c. And when you write it this way, you don't have to write the absolute value anymore, because no matter what x is, when you square it, it'll never be negative. So there's no need to write the absolute value bars here. And here's another example. So integrating 1 over 4x minus 1. So if you really think about it, if you know that the original or the antiderivative has to consist of the natural log, and you have 4x minus 1 in the denominator, somehow we had to kind of apply the chain rule here. Okay, and earlier in the video I said that when you have the integral of 1 over u du, so this gets a little trickier because where did the u come from? So this u, well, you have to let some part of this function equal u. So do the u substitution. So in this case, I'm going to let u equal 4x minus 1. By letting u equal 4x minus 1, so this stuff is all pretty much everything in the denominator, I now have 1 over the integral of 1 over u du. We kind of reach another problem, because here we have a du. So now we have 1 over u du. We can't have a dx. If we have the variable u, it wouldn't make sense to have dx here. They have to match up. So the dx changed to du. That is an easy fix, because you take the derivative of u, you have du over dx is equal to 4. If you then multiply both sides by dx, you get du is equal to 4 dx. Now, what I'm going to do here is I am going to now divide by 4, so that I get dx by itself. And I'll explain right now why. So dx is 1/4 du, or du over 4. Now let me just write 1/4 du. This is slowing down on me. Okay, now the reason why is because dx needs to get substituted somehow. Okay, so let me erase this du. Dx got substituted for 1/4 du, technically. Okay, and the constant 1/4 can come out using that constant rule. Okay, and this is the new integral that we have. 1/4 times 1 over u du. So this is 1/4 times the natural log of the absolute value of u plus c. But we know that u is actually 4x minus 1. that is the final answer. Okay, this is now the, let's move on to the integration rule for exponential functions. So, if you remember the rules that I had for the derivative of the exponential functions, hopefully it makes sense why the integral of e to the x dx is equal to just e to the x plus c, and the integral of e to the u du is e to the u plus c. Start doing some examples. So, right off the bat, I have to start with the substitution, just like I did in that last example with the natural functions, natural log functions. So, the trick here is that the u substitution should be the exponent. So, I'm going to let x squared equal u. So it might be nicer to organize this as a little side note here. Now I know that I'm going to make use of the derivative also, just like I did in the last problem. And that's 2x for this x squared. And if I go ahead and do times dx, that is now du equals 2x dx. And then just like I did in that last problem, I'm going to divide this time by 2x. The goal here is to get dx by itself. So dx is equal to 1 over 2x. Okay, and once again, let me reiterate this. The reason why I'm doing this is because now I have, oops, I forgot the du, but now I have a value to substitute in for dx. Okay, more importantly, I have a value that will change the dx to du. So, integrating 2x e to the x squared with my u substitution, now I have 2x e to the u, and then for dx, I am now going to use the 1/2 x, or 1 over 2x du. Okay? So some nice things start happening here. For example, 2x with the 2x cancel out. And this just becomes e to the u. So integrate e to the u with respect to u. That is just e to the u plus c. Always don't forget to end it by resubstituting in your original u value. Okay, which it was originally x squared. So the final answer is e to the x squared plus c. That's your final answer. And I'll just go ahead and stop it here. I'm going to end it here. We'll do more examples of these, especially with the u substitution. We'll do more examples like these in class. Like I said, it's just getting used to it by doing examples. I really just wanted to expose this to you in this video. So that is it.